Greetings to all of you. In today's session, we are going to discuss about intermediate level chemistry, which will be helpful for your international competitive exams or else any entrance if you are preparing for national level JE Advanced and JE Mains for IITs and NIT entrance exam for engineering stream, NEET chemistry for medical entrance examination, Telangana and Andhra Pradesh MSET exam for engineering entrance exam. In addition to all this, if you are writing any government examination, in that general science will be the common content you will get. In that also, the type of discussion what we are doing will very much helpful. Let's enter into our today's session. Here is the compound given. Explain the following compound as per the IUPAC protocol. We have to name the given compound in accordance with the IUPAC. IUPAC stands for International Union for Pure and Applied Chemistry, right? So according to that one, the name of the compound, if you see this, you can find bromo, chloro, methyl as the functional groups over here. Okay, and in this longest chain taken as the parent chain, and which direction we have to start numbering. Two ambiguities we have. Okay, either from right or left side you can start. If you start from left side, here substitution found at second carbon. If you start from right hand side, substitution is there on the carbon number 1. So that obviously numbering will be started from right hand side. If you start numbering over here, first carbon is with bromo, second carbon is with chloro, third carbon CH2, fourth carbon methyl substitution, and fifth carbon, so that it is the length of 5 carbons. So 5 carbon length chain, and in order to write all these functional groups, 3 functional groups, we have to follow alphabetical order. In that alphabetical order, B for bromo will come first, next will be C for chloro, and next M for methyl. So that let me put 1 bromo over here, and the second carbon we have 2 chloro, and fourth carbon resided with methyl, and the entire chain will be pentane. The name of given compound will be 1 bromo, 2 chloro, 4 methyl pentane. This is the way you can assign name for the given organic compound as per the IUPAC protocol, right? It will be 1 bromo, 2 chloro, 4 methyl pentane as per the IUPAC nomenclature. Move on to question number 2. Question number 2 is given from what we can say atomic structure. Which pair of atoms contains same number of neutrons? Electrons, protons, and neutrons are said to be subatomic particles. They are used to construct the atom, right? So electrons are revolving around the nucleus. Within the nucleus, you can find protons and neutrons, right? So when you see the atoms like cobalt, nickel, copper and copper, both are having same atomic number, different atomic mass. This is said to be isotopic pair. And in either copper and zinc will be provided. Among all, the question is same number of neutrons are required. We have to find out which are having same number of neutrons. Here is the condition. I am taking carbon as the standard reference, where in order to calculate number of neutrons, we have to consider its atomic weight and atomic number. If you subtract atomic number from atomic weight, you can find the number of neutrons. In the simple reference, I am taking carbon atomic weight as a 12 and atomic number as a 6. 12 minus 6, the total possible neutrons are 6. This is the way you can go for calculating neutron number. So simply we can say neutron number is equal to atomic mass number minus atomic number. Okay, so atomic weight minus atomic number is the formula for neutron calculation. So that we will follow for cobalt. Cobalt atomic number is 27, atomic mass is 59. Wherever superscript is there, always atomic weight it will be. Subscript is there, that will be atomic number. So that let me subtract 59 minus 27. The difference will be 32. This is for what? Cobalt. Move on to nickel. Nickel atomic weight is 59. Atomic number is 28. The difference is 31. Can you find same number neutrons? Whatever answer coming is the number of neutrons. So 30 to 31 not exactly mapping. Move on to option number B. Option number B, we have copper, whose atomic weight is 64, atomic number is 29. If you subtract, 35 is the number of neutron count. Move on to another, copper 65 and 29. If you see, both are isotopes, we just said, right? 65 minus 29, the number of neutron count will be 36. Again, there is no similarity. Move on to option number C. Copper 64, 29 will be there. 64, from 64, you can subtract 29. The value will be 35 number of neutrons. And zinc 65, atomic number 30. If you subtract 35, will be the neutron count. If you observe, both are exactly resembling, so that this will be the correct answer. In the option C, copper 6429, zinc 6530, both are having equal number of neutrons, right? So we will see the option number D also. So in case of D, 65 minus 29, 34 will be for copper atom. 65 minus 30, 35 will be for zinc. Both the neutrons are not exactly similar. So the correct answer will be option number C, right? For question number 2, option number C will be the correct answer. This is the question collected from Cambridge Assessment International Education. Move on to question number 3. Question number 3 is collected from JEE Advanced 2020 question paper. And here question paper, in that question paper, we have paper 1, right? So from that, this kind of question is collected. A colorless aqueous solution contains nitrates of two metals. Two metal nitrates are X and Y. When it was added to aqueous solution of sodium chloride, a white precipitate was formed. This precipitate was found to be partly soluble in hot water to give the residue P and the solution Q. Being it is partly soluble, a particular residue formed called P and solution generated called Q. The residue P was soluble in aqueous ammonia and also excess sodium thiosulfate. Sodium thiosulfate is called hypo. The hot solution of Q have yellow precipitate with potassium iodide. The metals are X and Y respectively. This is a kind of what we can say qualitative analysis. We are not measuring the quantity of reagents added or compound taken. Rather, just we are taking a known sample and drops of reagents were added. Based on the precipitate formed, based on the conformational test, we can identify the given metal or cation or anion. This is called a qualitative analysis and it is the analytical chemistry part. Let's see what is the sequential order in order to achieve the kind of question, in order to solve this kind of question. So the probable answer will be A. Silver and lead are the correct answers, metals like X and Y. Let's see how can we answer this. Okay, so here silver and lead will be the correct answer. So first compound, unknown compound will be silver nitrate. They said nitrates of X and Y metals, no? So silver nitrate is one metal, nitrates, lead nitrate is another. So when silver nitrate is added with sodium chloride, what precipitate formed? White color. What it will be? Silver chloride will be formed. And sodium nitrate is the aqueous solution only. This precipitate, silver chloride now added with what? Ammonia. Always silver chloride upon addition of ammonia that used to give the coordination complex silver ammonical chloride. Silver ammonical chloride will be formed. It is the water soluble solution. Then when silver chloride is treated with hypo, sodium thiosulfate, they said no, that is called Na2S2O3. This hypo solution when added with silver chloride, there is a formation of another complex Na3, Ag, S2O3 taken twice. Sodium silver thiosulfate complex will be formed. Again, it is mentioned in a square bracket, no? That's why we can say it is also complex. And this is also water soluble. Sodium chloride is discarded. So this is the way two water soluble solutions with ammonia and hypo are formed. So this is for what? For silver nitrate. Then let's examine lead nitrate. Lead nitrate upon addition of sodium chloride, that also able to give the exchange of ions, so that lead chloride will be formed and sodium nitrate will be discarded. Lead chloride is also white precipitate. Silver chloride is also white precipitate. So both the precipitates are together P only, right? So here lead chloride is also white precipitate Q. Whenever lead chloride is formed upon treating with potassium iodide, there is again exchange of ions. You can notice lead iodide will be formed potassium chloride. So lead iodide exists in yellow color. So this is the way we can answer yellow color precipitate they got at the completion of this question, right? So we can clearly mention that the given nitrates of metals are silver and lead. These are able to give the sequence of reactions what they are mentioning. For question number 3, option number A will be the correct answer. Move on to question number 4. Question number 4 is given from again IUPAC nomenclature. So which of the following structure has IUPAC name? 3-ethynyl, 2-hydroxy, 4-methyl, hex, 3-ene, 5-ionoic acid. Here the condition required is hex, 6 carbon length chain is required, and carboxylic acid. If you see all the compounds are having carboxylic acid, so carboxylic acid is common. And ionoic, ion means what? Triple bond must be present on 5th carbon. If you see the first compound, 2 triple bonds, you can discard this because they mentioned ionoic acid, not diionoic acid. So you can simply, by seeing only, you can cancel out option A, option B, option C. In 3 options, you can find triple bonds twice, so that from this single point only you can cancel out A, B and C. You can pick on D option. Why? Because 3-ethynyl and third carbon ethynyl, double bond will be there. Hydroxy is there, and the second carbon, if you see second carbon is having hydroxy and hexa. 1, 2, 3, 4, 5, 6 carbon length chain, so that hexa 3-ene. So on the third carbon double bond is located. 5-ionoic acid, 5-ine. So here is the triple bond on the 5th carbon, and being it is the carboxylic acid, this will be the main skeleton. You can note is alkanoic acid, so that 5-ionoic acid. This is the right representation. By using this 5-ionoic acid only, you can cancel out option A, option B, option C. So let's see in detail explanation about this one. First of all, we have to identify the parent skeleton. So in order to identify the parent chain of organic compound, we have to start numbering always from high oxidized functional group, that will be carboxylic acid. So that start numbering from this. So this carboxylic acid carbon will get first number, and second, third, fourth, fifth, sixth numbering completed, so that 6 carbon length chain you noticed. Longest chain is higher priority, shortest distance is also higher consideration, right? So after getting this kind of numbering, we have to go for alphabetical order. In order to give alphabetical order, hydroxy H, ethynyl E. So that let me put E first, so that 3-ethynyl will come first. Later on second carbon hydroxy is there, put 2-hydroxy over here, and the methyl next after hydroxy methyl we have to put. So 4-methyl will be there, and fourth carbon methyl you can notice. Then all 6 carbons indicated with the hexa. So hexa is indicated as the parent skeleton. And third carbon we have ene. Third carbon ene is there. Fifth carbon triple bond called ine. Fifth carbon ine is there. And leftover will be the carboxylic acid called oic acid. So according to IUPAC, oic acid is given for carboxylic acid. This is the way 3-ethynyl, 2-hydroxy, 4-methyl, hex, 3 5-ionoic acid is the complete name of the given organic compound. For question number 4, option number D is the correct answer. Move on to question number 5. This is the question given from physical chemistry purely, and most probably from thermodynamics, and equations are given. Their scientist names are given in either side, so that we have to map which is exactly uh, which scientist invented which kind of equation. So name of the reaction and scientist, that relation we need to find out. Among all, the correct option will be option 3. So let's see how can we explain this one. A with the 2. A with the 2 means what? Ln. Ln means log base E is called ln. Ln P1 upon P2 is equal to delta H vapor upon R 1 by R 1 by T2 minus 1 by T1. This is the equation invented by Clausius-Clapeyron. This is the equation. Here, this is the ratio of pressure 1 and pressure 2. When you are changing the pressure, how it is related with the temperature difference, that is given by Clausius-Clapeyron equation. And next is about St is equal to integration 0 to T Cv dt by T. So temperature differential they are taking, and here St denotes water entropy at constant temperature. So this kind of relation is given by who? Debye-Einstein. This is called Debye-Einstein equation, right? And ln K2 by K1 is equal to minus delta H naught by R into 1 by T2 minus 1 by T1. So temperature difference in accordance with the this is called a dissociation constant. This kind of relation is given by want of ln K2 by K1 is equal to negative delta H naught by R. H naught denotes what? Standard enthalpy difference by R 1 by T2 minus T1. Final temperature minus initial temperature. This is the equation corresponding Van 't Hoff. Okay. So d mu B by d mu A. This is the kind of ratio. So d mu B by d mu A is equal to minus Na by Nb. This relation is given by Gibbs-Duhem. This is called the Gibbs-Duhem equation. Let's see in detail. Clausius-Clapeyron equation in the thermodynamics. What is the role of Clausius-Clapeyron equation? Clausius-Clapeyron equation is the way describing discontinuous phase transformation between two phases of matter of a single constituent named as the Rudolf Clausius and the Benoit Paul Emile Clapeyron. So what they mentioned, discontinuous phase transformation among two phases explained by Clausius and Clapeyron. According to them, ln P2 by P1 is equal to delta H vapor by R into 1 by T1 minus T2. So this is a relation between the pressure difference to temperature difference. P2 is called final pressure, P1 is called initial pressure. T1 is called initial temperature, T2 is called the final temperature. This relation is given by Clausius and Clapeyron, which is mentioned in the option A, and that is 2. And Debye-Einstein equation St is equal to integration 0 to T Cv dt by T. So it is the temperature differential that is provided, temperature differential relation with the entropy change. So that is given by Debye-Einstein. Okay, move on to third one, want of equation. What is the use of want of equation? This is the data collected from Wikipedia and encyclopedia. Want of equation relates the change in equilibrium constant of chemical reaction to change in temperature. In what way equilibrium constant and temperature are related, that is mentioned by the want of. Okay, according to want of, ln K2 by K1 is equal to delta H by R 1 by T1 minus 1 by T2. So K denotes what? Equilibrium constant, and how the temperature variation changes equilibrium constant. That relation is mentioned by what? Whom? Van Tuff. So that is given over here, Van Tuff equation, right? So third one, C will be Van Tuff equation. And leftover will be d mu b by d mu a. This is the kind of ratio is equal to minus Na by Nb. That is called the Gibbs-Duhem equation, right? So what is Gibbs-Duhem equation? Gibbs-Duhem equation describes relationship between how the chemical potential change is related with components of a thermodynamic system. Okay, so there is a relation between change in the chemical potential with the components in thermodynamic system, that is given by sigma Ni d mu I is equal to minus SDT plus VDP. This is the kind of relation, okay, gives a Duhem relation for the chemical potential. Here I denotes what chemical potential, no? So when multiple components are present, so in that case, how this chemical potential change will affect the rate of reaction is described over here. Okay, final reaction will be d mu b by d mu a is equal to minus Na by Nb. This is the finalized equation, right? So this is called what the Gibbs-Duhem equation. So for question number 5, option number 3 will be the correct answer. Move on to last question of the session. Sixth question. And these are the questions collected from Gurukulam Degree College entrance examination conducted by Telangana State. Which of the following statement is true from the viewpoint of transition state theory of reaction rate? Okay, so when transition state theory is taken into the consideration, so in that case, the parameters like entropy and enthalpy, how they will be varied, they are asking for. Okay, entropy of activation, what will be the sign convention for that one, and enthalpy of activation sign convention is required to be mentioned. Okay, in order to answer that, first of all we have to see what is transition state theory, what it will explain. In chemistry, transition state theory explains reaction rates of the elementary chemical reactions. In what way, with what velocity reactions are progressing, reactions are moving forward, that kind of progress of the reaction in a chemical entity is explained by the transition state theory. The theory assumes a special type of chemical equilibrium that is called quasi-equilibrium. In the transition state theory, the equilibrium is designated as a quasi-equilibrium. That quasi-equilibrium is maintained between the reactant and the transition state complexes. Whenever reactant is reacted, finally we will get the product. Everybody aware about that one. So in between, there is a certain kind of transition takes place, changes observed. That kind of changes what we are observing in between the reactant and product, that intermediate state is said to be transition state. At the transition state, the molecule will be activated, the molecule will be excited. So that what relation between the reactant and the activated transition state of the given compound is explained by this transition state theory, right? So if you see, this is the reactant what we are taking. So let's assume metal is accompanied by A, B, C, D. These many ligands are there. Okay, this is the reactant molecule. It is moving in certain path. Whenever certain path it is moving, what happens? Slowly this C ligand is departing. So that it is mentioned with the dotted line bond. Departure of C ligand is carried over here. And whenever this C ligand is completely removed, we will get three bonded tri-bonded metal, and metal is bonded with only three ligands A, B, D. C is discarded over here. In order to, so reactant will be metal with the four bonds, product will be metal with the three bonds only. In between there is a certain excited state, the certain activation state will be achieved around the central metal, that is said to be its a transition state. The transition, in that transition state, what happens slowly, reaction transformation you can notice. In what way reaction is progressing, it is proceeding, that you can notice slowly. The C ligand is departing, mentioned with the dotted line, where delta S. Delta S is said to be negative. Delta S is taken as the negative. Delta S means what? Change in the entropy. Change in entropy is mentioned as a measure of disorderness. Measure of disorderness will be negative, means low. Enthalpy of activation delta H is positive. Enthalpy of activation positive is nothing but the reaction is endothermic. It requires some external energy. It added with some external energy, so that it is said to be endothermic in nature. The required parameters for this transition state will be delta S required to be negative, enthalpy delta H of activation is required to be positive. Entropy of activation is a negative, but enthalpy of activation is positive. These are the requirements for the transition state of the given organic compound. So that is given in the option number 2. For question number 6, option number 2 will be the correct answer. By this, we entirely completed the session, and intermediate level chemistry got covered, and different dimensions we observed: organic chemistry part, analytical chemistry part, physical chemistry part, inorganic chemistry part. Various dimensions we covered over here, and a detailed description is provided, and the entire thing is available in the channel called World of Competitive Chemistry. And we are doing same series of sessions in these days, so that this will be really helpful for any competitive exam you're preparing or entrance examination. So I'm sincerely requesting you to like the channel, comment which is required part for you, and share with the aspirants who are seriously preparing for, and subscribe the channel to get continuous updates regarding this kind of content. And thank you very much for your patient listening. Thank you one and all.